MKS-20 piano module on my bench, and arguably it's one of the most iconic piano sounds of the 1980s, probably second to the DX7. This particular unit is having some issues, however. One of the most obvious things is the backlight on the display is burnt out. The LCD is working. You can read the display and everything is functioning correctly. It's just there's no backlight. The next issue is the volume control is quite noisy and it's got a lot of static and crackles. As I adjust it, you can hear the static. It's quite annoying. Another issue this unit is having related to the output is an overall distortion. Here, let me play a full chord. You can kind of hear a distortion, a muddiness. It should be crystal clear. This is a common issue with these units. The audio output goes through a bypass relay. And what that's for is when you turn the unit on, it usually shunts the output to ground momentarily. That way you don't get any thumps or clicks when everything powers up. And then after a few seconds, the relay switches to the other position, and then it shunts the output of the synth engine to the outputs on the back. The problem is, over time, the contacts in this relay corrode, so that it ends up distorting the signal and you get this weird muddiness. The final issue with this unit is the battery for the memory has never been changed out. So it's got the original battery in it, and I definitely have to change that. So right now, the only thing left to do is open it up and get to work. With the top and the front off the unit, I have easy access to the volume control, the backup battery on the CPU board, and of course the LCD and the backlight on the front panel. The bypass relay for the outputs is on the back and underneath, and I'll get to that later. But the very first thing I wanted to focus on was the LCD and the backlight. I've got my benchtop meter connected to the power leads going to the backlight. Unlike a traditional LED backlight, this unit uses an electroluminescent panel, this thin wafer-looking panel. And how this works, it's essentially a plate capacitor. So there's two conducting plates, and the dielectric in between is coated with a phosphor. So when you charge the plates up, the phosphor glows, and the panel essentially turns into a light, a panel of light. One obvious advantage of these electroluminescent panels as opposed to LED backlights is they're super thin. So they can fit into much smaller displays, thinner displays. They're just easier to physically fit into a unit. The other advantage is when they glow, the entire panel glows as one unit. So you don't need clusters of LEDs or diffusers or anything. It's just one panel and it glows. There is a drawback though. To power these units, you have to give them high frequency, high voltage AC. So up to about 100 volts at about a kilohertz to run one of these panels. Now that sounds kind of dangerous, but the current is very low, so it's not dangerous at all. But still, it requires that you have some sort of inverter circuit somewhere in your design. So what an inverter circuit does is it'll take DC voltage in, pulse it, run it through a transformer, and then you get AC voltage on the output of the transformer. and the transformer will step up the voltage but step down the current. So on this unit, there's a circuit just behind the front panel, and it takes 5 volts DC, and the output should be around 100 volts AC at about a kilohertz. The service manual doesn't give any indication on what the output should be, so I'm kind of guessing at this point. So let me turn everything on. It takes just a second before it turns on. So my benchtop meter is set in the frequency counter mode, and you can see that it's showing just above 700 hertz, so about 730 hertz. So that's pretty close to a kilohertz, so that sounds reasonable. So let me switch it to volts AC. And it's incredibly low. It's even lower than it was earlier before I started the camera rolling. It's only showing about 8 volts RMS, and that's really low. I suspect that the electroluminescent panel that's in there right now has failed in some way, and it's acting as a resistive load, or it's loading the inverter circuit in some way. I'm hoping that that's the case. What I'm going to do now is I'm going to turn everything off, disconnect the power from the old broken backlight panel, and I'm going to temporarily connect this one to it to see if I can get it to glow. I have a precarious setup here right at the moment. I had to unscrew the LCD unit from the main front panel so that I could get access to desolder the power, and I have the power connected to the new electroluminescent display. And I'll turn things on. And success! The display is now glowing this nice light blue color. I'll turn the lights off in a moment. You probably can't really see it on camera. But the other thing is, the multimeter is now showing 93 volts AC RMS. So my theory was correct. The old backlight was loading down the inverter circuit, and it wasn't able to supply the power required. So let me turn the lights off and you can see the blue color. So now I'll start the actual work. I'll remove the old backlight, put the new panel in place, clean the volume control, replace the backup battery, and replace the output bypass relay. I'll narrate here in the background while you watch me work. The first thing to do was to remove the old electroluminescent display and replace it with the new one. And just look at that display glow. Beautiful. After that, I desoldered the old battery from the CPU board, but I replaced it with a battery holder because then it makes it easier to do a battery replacement in the future. And here I'm popping in a new CR2325. And now the prerequisite shot with some deoxit on the volume control. Now I'm just turning things over to get access to the bottom so that I can get to the effects and amplifier board, and that's where the output bypass relay is. Some more desoldering to remove the old relay. And there's the old relay. You can barely see the contacts through the transparent cover. And now I'm ripping through the packaging to get to the new relay. And I'm just going to check it with the old one and compare it to make sure that I ordered a suitable replacement. And now just soldering in the new relay. And here I'm doing a quick cleanup on the front panel with a Kim wipe. And finally, it's just reassembly. The backlight repair was a success, and replacing the output bypass relay and cleaning up the volume control cleared up the distortion issue. That's it for this video. Thanks for watching.